Hello students, today we are going to see an interesting and important topic, that is isomerism of coordination complex compound. Already you have learnt in organic chemistry. The concept it is same, molecular formula it is different. This concept also same molecular formula, different structural formula. That is what you have learnt. The same concept only here also. See, isomerism is nothing. Same chemical formula but different arrangement of an atom or group. Okay, now here physical and chemical properties also vary. Okay, now for example, as I mentioned this formula, I hope you are knowing very well the nomenclature of coordination compound. See, this is, do you know what is the name of this? Diamine dichlorido platinum 2. Right. Okay. Now, different arrangement means how do we identify this? So, the same molecular formula, but different arrangement. Now, for example, platinum, here ammonia, this side ammonia, cis and trans, let us bring here chloride and chloride ion. Here also the same. Pt, here NH3, here NH3, here Cl and here Cl. So I think you are remembering that cis and trans isomers, the same molecular formula, but different spatial arrangement or different arrangement of an atom. Such kind of point we are mentioning. I'm giving that example only. Right? Come on, let us go and clarify all those particular ideas. Come on. First and foremost, what are the different types of isomerism? So, the different types of isomerisms are stereoisomerism, structural isomerism. So, what do you mean by stereoisomerism? In coordination compound, same molecular formula, that means same chemical formula and chemical bond, but different spatial arrangement. Here also they mentioned the same idea only. So, what are the types of stereoisomerism? Here really it will be interesting, and this is very important also. So, structural isomerism and optical isomerism, so these are the two types belongs to the stereoisomerism. Whereas here structural isomerism is common, same molecular formula, different structural arrangement of atom or group of the central metal ion. Here always we mention that central metal ion. See, this is the central metal ion around that ligand. In that way we can identify. Okay, now what are the types of structural arrangement of it? So, who are those children of structural arrangement? Structural isomers means linkage isomers, coordination isomers, ionization isomers, and solvate isomers. The types of structural isomers only I just mentioned, the children of structural isomerism. Okay, now each and everything we will learn in a detailed way with example and with important questions also. Now let us go and learn each and everything in a detail. First and foremost, geometrical isomers. What it has mentioned, heteroleptic complexes due to different structural arrangement of ligand. This differs in the relative position of the same group around the central metal atom or ion, means that is cis isomer. If it is opposite to each other, means that is a trans isomer. Generally, heteroleptic complexes only it's the eligible for geometrical isomers. So heteroleptic means different kind of atoms. The same example we can bring it. PtCl2 NH2 twice. Okay, now as we are writing here, Pt here NH3 and this side also NH3. So same groups are around. Here Cl, here Cl. This is cis isomer. Now for example, trans isomer, this Pt here Cl and here Cl opposite. NH3 and here NH3. So this is trans isomer. Right? So this is the way we can identify. Okay, which are the complexes are possible for geometrical isomers? Let us go and learn. First and foremost, which is not possible, let us finish it. Tetrahedral complexes do not show geometrical isomer. Mainly, tetrahedral complexes do not show geometrical isomers. Why? Because all the positions are adjacent to each other, right? So, adjacent to each other means what it is? It is identical. What is the main point here? Heteroleptic complexes only, it's a main point, but here tetrahedral means it is actually a same kind of atoms, so that means it is not possible. So tetrahedral complexes do not show geometrical isomers. Please note down. Okay, now that means which are the complexes are possible. So square planars are possible, octahedral complexes are possible. So which are the way we can identify? Mx2L2. M means what it is? Central metal ion. And X2L2, it is a monodentate ligand. And X2L4. Mx3Y3. Mx2, this is didentate ligand. So these are all examples with clear explanation with the diagram. Let us go and learn. Now the first one, square planar complexes Mx2L2. X and L are unidentate ligand. How many geometrical isomer are possible? Such kind of Mx2L2 means two isomers. How? Like X and L. So this is one isomer opposite. That means X may be arranged adjacent to each other means that is cis isomer. Opposite to each other means that is trans isomer. Now we'll take this example. PT, it is a central metal ion, NH3 and here NH3. The same way here Cl and here Cl. Opposite to each other, PT, here NH3, here NH3 and here Cl and here Cl. So this is trans isomer, this is cis isomer. So two isomers are possible. Hope you're clear with this example. X2L2, such kind of example comes means whether you are able to identify how many number of geometrical isomers are possible. Yes, I hope you got an idea. Okay, now let us go to the octahedral complexes. The next one, octahedral complexes Mx2L4. In this, how many geometrical isomers are possible? Means only two. How? Because X it is 2. So in this, X may be oriented cis and trans. So in this, for example, COCl2 NH3 4 times. Which is the central metal ion? CO, it's a central metal ion. So in this, NH3 4 times, right? So NH3 and here NH3. So in this NH3 adjacent to each other, that is called cis. Adjacent to each other, so that is called cis isomer. So this is cis, that is CO, Cl2, NH3 4 times here positive charge. So this is purple color. Purple. Whereas trans isomer in this CO, the same molecular formula only. So CO opposite to each other. So this is how NH3 it's common. NH3 here also NH3. Here NH3 opposite NH3. Here Cl. Here Cl. So this is opposite to each other. So this is what it is. Trans isomer. So trans isomer here the same CO Cl2 NH3 4 times. Right. So what is the color? Green color. Hope you're clear with this example along with this Mx2L4. Okay, so this is actually what it is. Octahedral complexes. This is 4 plus 2. Right? Okay, now in that, next to one more example, let us go and identify. Now the next one, Mx3Y3. This also belongs to octahedral complexes. How many geometrical isomers are possible? It is 2. And what are they? That is facial and meridional. What is the example? CONH3 thrice, NO2 thrice. Come on, let us go and identify them. So that is central metal ion CO in this four ligands in the last one. So NH3NO2. So here NO2, NO2 and here NO2 and this NH3, NH3 and here NH3. So this is facial arrangement like. So what happened here? It's the same way here. So this is facial isomer. Next one meridional. Okay, meridional. What is the central metal atom? CO only here also. Okay, now here just to the opposite. Here NO2 NH3. Here NO2 and here also NO2 and here NO2 NH3, here NH3, here NH3 and here NO2 NH3. Okay, now here this is what it is, meridional, something different. Okay, now you see here in this NO2 NO2 NH3, whereas this side NO2 NH3 NH3. See, these both are similar and these both are different. In that way we can identify, whereas here same. So this is facial and meridional. Okay, now we are going to see another one more example of what it is, geometrical isomer. Now suppose bidentate ligand appear. So what is the combination? MX2 LL twice. See, ethylene diamine comes such kind of. So how many geometrical isomers are possible? Only two, that is cis and trans. Example, COCl2 En twice. Okay, let us draw that structure. Which is the central metal ion? CO, it's a central metal ion. Okay, now in this octahedral complexes only in this way. Let us draw like this, and this Cl and here also Cl. Okay, in that ethylene diamine comes like this, right? Ethylene diamine comes like this, En, En. This is cis. Okay, whereas trans, the central metal ion same CO. Okay, now in this, so Cl and then here Cl. This side, what it is? Ethylene diamine. So this is ethylene diamine. En. Okay, so this is what it is. Trans isomer. So this is cis isomer and that is trans isomer. Hope you're clear with that geometrical isomers of all kind of examples. Okay, now we are going to see optical isomers. Optical isomers are so simple in coordination complex compound. The same concept only we are following. Identical physical and chemical properties. It differs only in the direction which they rotate the plane of polarized light. A simple way we can tell optical isomer, always unsymmetrical shows optical isomers or dissymmetry. Okay, now the next one more point, it's very important. One more question or two more question they may ask. The optical isomer or mirror image which cannot be superimposed on one another, that is called enantiomers. Listen to that. Here, the optical isomer or mirror image which cannot be superimposed on one another. Now you see this hand. So this is actually optical isomers. When we are keeping on one another, this cannot be superimposed on one another. So this is enantiomers. Here, molecules are ions that cannot be superimposed. That point which is called chirality. Now the next point, what it is? very, very important. What are the examples? Tetrahedral complexes, octahedral complexes. These both are suits for optical isomerism. But whereas geometrical isomerism, tetrahedral complexes will not suit because they are identical. Okay, now here A, B, C, D, M of A, B, C, D. These A, B, C, D are different ligand because they are optically active. And here M, A thrice and M, A twice, B2. Okay, now these examples, let us go and see the complete idea. Okay, here COEN thrice 3 plus. Okay, how do we draw this central metal ion? CO. Okay, now here in this N and N here, ethylene diamine, no, this is N and N here N. The same way optical, right? So here what happened? So like this, it will be because a ring, na? Okay, now here the same way CO. Okay, now here and this also N and N. Okay, now here the same idea we just follow. See here, actually both are mirror image. Like this it will be there. Okay, now one more thing example it has given. In this COCl2En twice. Actually COCl2En twice, even geometrical isomers cis and trans we have seen. Okay, now in the trans we cannot identify, but cis we can go for it. Okay, now CO in this. Okay, now this is Cl and this is Cl. Okay. Okay, now this is what it is. En, right? And this is also En, right? Now the opposite side, okay? Now opposite side the same, CO. Here Cl and here Cl. And here what it is? En and this side En. Okay, ethylene diamine. Hope you're clear with that. Now you see that mirror image which cannot be superimposed. Hope you're clear with this examples. They may ask that diagram, especially they will give the formula and they will ask you to draw such kind of diagram in that optical isomers. That is very important. Hope you're clear with this. Now the next isomer, structural isomer. In that first one, linkage isomer. In that linkage isomer, what do you mean that? Same molecular formula but differ in the linkage of monodentate to the central metal atom. So whenever you see linkage isomerism means, please remember ambidentate ligand. Ambidentate ligand that you have learned in the classification of ligands. Okay, now in that, so ambidentate ligand at a time any one can attach that ligand, both the atom any one can attach to the central metal atom or ion. Okay, now they have given example pentaamine nitrito cobalt 3 chloride. In this NO2 ONO also it may act or NO2 also it may act. Okay, now let us see that what are the two different kind of formula. The first one CO NH3 5 times ONO Cl2. The second one CO NH3 5 times NO2 Cl2. Okay, now what is the name of this? Okay, when central metal ion attached to that oxygen, so what is the name we can provide here? Pentaamine nitrito, nitrito, O cobalt, cobalt 3 chloride, chloride. See, oxygen which is attached to that central metal ion. Whereas here, pentamine, pentamine, nitrito, N, cobalt 3 chloride. Okay, now this one, what is the color of the first one? Pentamine nitrito O cobalt. You know what is the color? Yellowish brown. Yellowish brown. Okay, the second one, pentamine nitrito N cobalt 3 chloride. That is N. Then color it is a red color. Hope you're clear with this linkage isomerism. Now the next one, coordination isomerism. Let us go. Now the next one, coordination isomer. This coordination isomer will happen only in the coordination compounds, and this is exchange of ions, that is cation and anion. Now you see this isomers involve exchange of ligands between the complex ions, the cations and anions between the coordination sphere. Okay, now see this example, CONH3 6 times, CrCN 6. Okay, now in that NH3, that is a cation, that means CONH first point which is called cation, the second point which is called anion. So NH3 can bond with that Cr3 plus. The same way Cn minus which is bound to cobalt 3 plus. So that is the exchange of ions between the coordination sphere. Okay, now the next one, what is the isomer? Let us go and find. Now the next one, ionization isomerism. This is so simple. Exchange of ions inside out of the coordination sphere. Okay, inside out of the coordination sphere means example COBrNH3 5 times SO4. Now that is pentamine, bromido, cobalt 3 sulfate. Now in this, the second one, sulfate ion gone inside, that bromide comes out. So exchange of ions. Okay, now what is the color? So exchange of ions also, it will be vary, the compound completely vary. Okay, so this is red violet color and this is red color. Okay, how to identify? This is sulfate ion is there. No, let us go for sulfate test. What is it sulfate test? BaCl2. So when it is BaCl2, when we add, suppose sulfate is present means what color we will get it? White PPT we will get it. So that means we can identify sulfate it is present. Whereas here BaCl2 if we add means it will not answer for BaCl2. You will not get white precipitate. Whereas if you put AgNO3, AgNO3 if you put means you will get AgBr precipitate. So from that we can make out bromide ion which is present. Hope you're clear with that ionization isomers. The next one, solvate isomer, which is the last isomer. Let us go and identify. Solvate isomerism, the main point it is water molecules only. Same formula but differ in the number of molecules of water as a ligand. So this is also known as hydrate isomerism. Okay, now this is actually similar to linkage isomerism. Linkage isomerism, which is what it is attached to that metal, a central metal ion. Now the same way it is differs. Okay, the same way here, similar to this linkage isomerism, and it is actually similar to what it is ionization isomerism, exchange of that. See, isomerism differ from each other by number of water molecules present inside and outside of the coordination sphere. They have given one formula CrCl3 6H2O. Now, what are the compounds? How many isomers are possible? Here, Cr, H2O, 6 times Cl3. Okay, so 3 chloride ions are ionizable. Okay, whereas here another one Cr H2O 5 times Cl2 H2O. So 2 chloride ions are ionizable. Whereas the other one Cr H2O 4 times Cl2 ClH2O. Okay, see that inside out exchange. So this is only one chloride which is ionizable. Now, what is the color you know? This is violet and this is blue green and this is what it is green. Easily we can identify. Okay, now this, how to identify all this silver nitrate solution if you put, it will be answer for chloride ion. Hope you are clear with that. All the isomers and examples, these are all 1 or 2 more questions they may ask and mainly they will ask, choose the correct answers. Okay, hope you are clear with that isomerism. The next topic which is Warner's theory, VBT theory, crystal field theory. These 3 theories, let us go and learn. Okay. Thanks for watching. Please subscribe this channel so that you will get all the notifications. Thanks for watching.